So we are Studio AATB, Thibault and Andrea. So we will share the screen. We are a studio that we define as a practice for non-industrial robotics. What we mean by that is that we use industrial robotic systems and automation techniques, and we try to get them out of factory and try to see what is possible now with these sort of machines. The way we started to use this was a long way. It's not like one day we stopped using our laptops and we just started using robots. We studied graphic design both. And 10 years ago, we discovered Arduino, and we had a bit of interest in like engineering and like exploring like the technical aspect of doing graphic design. But Arduino was really a trigger to really start to build our own tools. So what you see here is the very, very first printer that we developed. That was called carbon copy paper printer, using just a carbon copy, because there is no way to print with this. So by this project, we were really building from scratch a little processing app that was allowing us to feed it black and white images. And then it would drive with a little Arduino, this printer that would go and bang on the paper wherever we wanted to have a black dot. So that was really the first moment where we kind of completely got in control of the whole pipeline of producing graphical assets, from the first line of code on the computer to the last nuts and bolts that were moving the printer. And that was really, for us, a really key moment into developing further on projects that were really about appropriating and reappropriating technologies that we use in our daily practice. So this project was then developed further on, and it became our diploma project called Grand Central. Grand Central was about having a website, so everybody around the world could go on the website and leave messages, a bit as a public Twitter, like anonymous Twitter feed. And it was connected to this huge mechanical plotter that was a bit acting as a guest book. So any message arriving on the website would land and be printed on this paper, and it would leave this sort of like dialogue between everybody online that would arrive on this physical space where the plotter would be exhibited. So that was also something that we were interested from really a long time ago, is this link between the virtual, the online, sort of distributed environment, and then connecting it to a physical space, with having a physical reality, and the way these two can dialogue and talk to each other. One key aspect also is that because we build everything ourselves, we try to build it in a way that is very generic or reusable. So this printer, we design all the plans in a way that it's almost like a parametric printer. We can make it bigger and smaller, and then all the plans update. And so that led. So this led us. So this diploma project was called Grand Central, and then 2 years later we kind of like reshaped it and did Petit Central, which is like basically the little brother of Grand Central, and it was kind of using the same plans but just in small. Then also we developed a larger version of it, basically installation that used 18 times the printer, kind of a bit modified Grand Central, and there was kind of used at the opening weekend of the Venice Biennial for Architecture. Basically, it was kind of building the backdrop of a conference that was taking place, and while the conference took place, on these 18 printers, there were the results of the conference being plotted as backdrop for the conference. So we were also commissioned by the Harvard Library, and they asked us to make a project around civil rights. It was around 2014. It was for an exhibition at SXSW in Austin. And we developed this project called Constitugo, which was a little detonator that would plug into like regular ticket printers. And you would just like go in a shop, you plug it, and then when you just trigger, and you would print out a copy of the US Constitution. So in 6 seconds, you have a 2 meter long ticket with the full US Constitution. So that was for us also an interesting departure from our graphic design practice, because it was not anymore even about building tools for producing graphic outputs. It was also about rethinking the whole network, the whole way we distribute content, the whole way the designer can almost become suddenly a hacker. We use a lot of electronics. We use a lot of way of subversive systems to try to deviate of the intended use case. And that was a bit the way we got slowly into like mastering a lot of different technologies. So we are not experts we are not experts in electronics, we are not experts in programming, but we have a very wide range. And having all this kind of overview of the technical aspects, we realized we were constantly building machines that were almost becoming robots. Even though they were very simple, for us it was always about having some sort of input information, some sort of behavior to decide about things, and then a way to act on the world. So having this input, decision making, and then output, that's a bit an abstract way of defining a robot for us. And every time we were rebuilding machines, and it felt a bit like reinventing the wheel every time. And so about 4 years ago, we attended a conference where we got to play with this huge robot. And that was really a turning point, because we realized that even though it felt extremely far away in terms of like it's really like industrial systems, it feels like it's just another class. It's not like just going in a workshop in a design school and you can use a bit of woodworking machine. It like that felt like you go into real heavyweight factory. But suddenly we realized that it's not that much more complicated. Like in terms of logic, in terms of programming, it's just like some motors. It's just heavier, but it's the same concepts that when you build a customized printer, it's all the same ideas. It's just bigger and stronger. So from then on, we decided that we would really push the practice in this direction.
Yeah, and so we went on, like, after attending this conference, we really kind of like this idea of buying a robot did not get out of our minds. And so we went on Craigslist and like eBay Kleinanzeigen, and like not so long after we bought our first industrial robotic arms. And this was really at the time where this was about 3 years ago. So we then officially founded AATB. I mean, we have been kind of informally working together for 10 years, like as we met during our studies. But then like 3 years ago, we really like decided to officially formalize this collaboration and working with robots. So we had our first one, and now we have a family of 4. So it's
growing.
Family is growing. Like one of our first project we did was a workshop at ECAL, like back in the school where we have been studying at the Type Design Masters. And we kind of gave a workshop on, like this, the subject of the workshop was grève générale, like it was kind of strike, in English, like strike. So basically, with the students, they had to design kind of strike signs against the automation of labor. And we found this quite funny to do it with a robot. So basically what we did was developing a very, very simple software in which the students could draw their paths, and then basically they could just define the depth and the angle of the tool. But they had they had no visual feedback of this. So they had kind of to imagine this. And then while cutting, there was really kind of this 3D object appearing. This is kind of like the result of the workshop.
Then we also try to push further the research more in like the performative aspects of robots. For us, like, it's interesting that robots used to be in factories doing a million times the same movement, but they are completely generic in the programming that you can do with them. Like, you can make them a million different movements instead of a million times the same. So it's really about rethinking what is possible now today with this type of robots. You can see in the picture here, like the robot here is this kind of, it's a new technology that is called collaborative robots. And compared to the previous one, the orange one, they are much more safe to interact with public, with students. They are much more easy to program. And that opens up a lot of new use cases that are just not imaginable. Like, you would not do this kind of stuff with the orange one because it's just too dangerous. Like, this one has a very high level of safety, so it's not meant to bump into people, but if it does, it's going to stop automatically, and you don't risk much anything. So that opens up a whole set of new applications. So this workshop that we titled the Center for Counterproductive Robotics was really about thinking about what do robots when they are not producing anything, they are not producing like value in terms of material value, but they really can become more like performers in a way. So that was about thinking of new applications, like new sets of moments where they can take an active role. And that also led us to develop this project that we called Sunnyside Up. That is exactly about this. It's not a robot that is producing material value in the sense of an actual object, but it's about the movement that is possible with this. So the robot moves exactly like the sun. So it's a sun clock. And what it does is the lamp moves exactly as the sun outside. So if you're inside and you spend the day at the desk, you feel exactly the same as if you would have the sun passing overhead along the day. And that for us is also very interesting, is that now we can have some sort of kinetic objects that really can have like logic, like programming logic, but embedded in their own movements. So not just like something that can move in a very simple manner, but now you can have a lamp that moves like the sun, and suddenly the robot allows you to do this. So this was in Ars Electronica in Linz, and it was exhibited 5th floor underground in a bunker. And that was really what we envisioned in the beginning. It's like asking this question, like what happened when we recreate the nature world, and it created this weird situation where we still experience the natural world, but it's very artificial at the same time. And so it's bringing all these new questions that robots are. It's really interesting, like what robot put on the table. Like, we can reproduce a lot of things, a lot of movements, a lot of human behaviors, but somehow there is something missing, and we are questioning also all these aspects through our work.
This is a soap opera, it's an installation that we were commissioned by the V&A in Dundee, basically in preparation for the Hello Robot exhibition. And it's basically it's a robot that blows bubble all day long. And for us, it's really kind of like, in a way, it's a very contemplative piece to look at. But on the other hand, it's also kind of, it has some deeper meanings, because when we were doing some research, we found that in the kind of paintings from the 16th century, there was a lot of these vanitas paintings. There were always kind of the bubble blowing there were images of bubble blowing boys, and the bubble is kind of an image for the fragility of life, and something exists, and in the next moment it pops. So it has this kind of deeper meaning to it. And also it's kind of like, in this project, we really try to look at the robot not from a kind of like technical point of view, but also we just try to we try to be choreographers for the robot. So like all the details of how the robot moves were really important to us. And also kind of like testing a lot of the right mixture of subtle Yeah. Sorry.
And so that's also leading us to do a lot of projects that involve interactions or somehow movement. But we don't always work with actual robots like robotic arms. We also try to explore what is possible by like Arduino in combination with motors and sensors. This project was called ISS. We did for the Biennial of Design in Istanbul. And it was about inviting people to look up at the sky, the night sky, and specifically when the International Space Station is passing above. When it's passing above, it's circling 16 times the Earth per day. And in the night, very often it's very easy to see it by just naked eye, even from the center of a city. So this was staring all day long at the ISS and inviting people to look at it. And from this, we did a clock that works a bit as a mix between the sun clock from before and these eyes. So this is a conceptual view. The eyes always stare at the sun. So we compute all the time the direction from the sun. And so wherever you look at the eyes, you know where the sun is as they pass at like noon, and then the sunset and sunrise are exactly at the horizon. And that's kind of a very simple project. It's just like these two eyes that rotate. But by bringing also this kind of deeper layer of meaning at what information you're looking at, for us, it's also quite interesting. It's a bit like the project that we showed before with the sun clock. It's just a light moving, but you know that it's the sun behind. That's the information driving it, or these eyes are also staring at the sun. And so for us, that's also quite important. Is the meaning of the information behind. So it's not just the eyes turning once per day. It's what's behind.
This is our next project called Phasma. It's kind of as we have been learned during our practice, as we have learned to design PCBs, we kind of noticed that PCBs are very often designed by engineers and printed circuit boards. They are designed by engineers, and the designer takes them and puts and hides them in an object. But so we kind of noticed that we could also use them as an object itself. And so we were developing this modular lighting system. So basically, you have a set of very simple elements that you can bolt together, and then if two elements are bolted together, they connect, and you can create sculptures with light. This is a product we are soon releasing.
This is also quite important to us in our practice. It's that through a lot of the projects we do, it's really just like really researching and experimenting without a clear goal. So a lot of the projects we do are not about developing products, but somehow through a lot of the expertise we've built up, we have this sort of side projects, almost like spin-off projects that come out and then allow us to develop, let's say, more commercially viable projects. So this is a bit like an offshoot of the last 8 years of having learned to do circuit boards. Now suddenly, not just building little boards for every project, but now building whole projects out of it. That's also interesting for us, and this is also something we are doing now with robots. That the knowledge we've acquired allow us to develop new commercial applications in what we've learned.
Mm-hmm. So since a bit more than 2 years, we're designer in residence at this in Arles in a foundation called Luma Arles, and we are at Atelier Luma. And Atelier Luma is kind of a design residence and research center, and basically they're building this huge museum, and that is they're building a new park. And we were approached by Luma to work on some architectural details for the park, and we have been working for 2 years on some kind of concrete tiles for pathways that will go in the park. And we have been using some algorithms that occur in nature, reaction diffusion algorithm that exists in animal skins. And basically we have been developing a software that allows to kind of like draw the pathway ourselves, and then the algorithm grows in the path, and then we have this kind of like pattern that occurs on the surface. So we have been developing a set of concrete tiles, and then so it's half concrete and half earth, soil. And so basically what is now brown will eventually become green as grass will grow it.
And so that's also something that in our projects is quite strong, is we program and we learn to code. And so a lot of the projects we do involve a lot of programming and web programming also. We do a lot of like customized server APIs, and a lot of our projects are run through some like dashboard interfaces. And we use a lot of processing also. So we are very, we have a similar approach to Tim's practice with a lot of like processing heavy projects. And this next project is also heavily based on processing.
Basically, we were commissioned to do a huge print for the World Economic Forum. When we had to print this huge map that a friend of us was designing, and we had to. So it's like 7 by 3 meters, and we were developing a software again that would allow us to place dots on a surface. And then we could print with the robots these kind of dots. So basically it was printed with some LG pigments. And then, so this were some first tests. And then some next tests, and then this kind of the final result.
And so for us, that's also very interesting that in a way, this project was extremely similar in the process at the very first printer that we showed. The first printer was very crudely built, like with just hot glue gun and just like tape. But it was still the same idea. We had a processing sketch that was eating an image and then like digesting it into commands for the machine. And then like the machine would go and trace dots. So it's just that 10 years later now we have upgraded all the techniques to do this, but fundamentally it's the same approach we had as graphic designers like many years ago. So that's, for us, it's also nice, but in a way we didn't change our practice. It's just that in the beginning we had no clue what we were doing. We were more like just fooling around with technologies that we had no clear understanding of. And then we've been just like refining everything we've known, and now we use robots, but it's just going back all the way to just like buying a $20 Arduino and just like trying to like mix together something that sort of worked. And yeah, like that's the final project we can close on. The one we just launched a month ago. It's called Handshake. And so obviously it derives from the current situation. And the idea is very simple. Right now, we can't touch people, or like now we can slowly more and more touch people, but it used to be that it was not that easy. And so we wanted to make a project that was based on this idea, but also almost more universal in a way. But how can you connect people that are remotely spread around the world, but somehow want to have a physical interaction? And so you can go on this website. Actually, you can go right now. It's still online, handshake.aatb.ch. And you can take control of one of the hands. And so wherever you are in the world, you can control one of the hands, and somebody else can take control of the other hand. And you can play together. And this is live from our studio. So it's a bit the same idea as the printer, where you would send messages and then they could get all printed out in this paper. Just here, you're just playing with the hand, but still there is an actual physical act that is happening in the studio. The hands are really there, moving and driven by you. And so that's also for us something quite interesting, is to question just the values of the purely virtual experiences, the purely screen-based experiences, and add also this physical part that can add a whole new layer of meaning, because the hands, you're actually controlling a hand, and you're actually touching the hand of somebody remotely. So that's for us, that's this kind of like very interesting project where it's pure research, but somehow they talk to a lot of people and about a lot of things, because now we build this entirely ourselves. So that's, for us, it's also the whole thesis of the studio is based on this idea that the robotic technologies are a bit at this same threshold point as Arduino 10 years ago. Arduino completely changed the way we can use technologies in design schools, as artists and designers. And today, robotics are a bit at the same point. They are entering a stage where they are more and more easy to use. And so suddenly you have an explosion of new applications that are possible. And this project is clearly an example of this. Like we've not learned programming in school. We've not learned robotics in university. We don't have a PhD in all of that. But somehow we could completely build ourselves that. And so that's symbolic for us of this change that is going on right now. And that's the way, the reason why we founded our studio practice, to explore specifically this change going on. So you can go on the website. You can see it here, the address, if you want to test. And we will likely take a few questions now. So thank you very much.
Cool. Thank you very much for your time. Super inspiring. Thank you. I really have to try that hand thing later on. Is it in the back of your studio or?
Yes. The studio is 5 minutes away. You can go right now. It's live.
Nice. Okay. Let's start with some questions. I mean, there was one about your workshops and projects. And in your workshop and projects, you're applying robots to everyday situations. Some of the ideas are very playful, and some of the robots' tasks and their movements are very much mesmerizing. Can you elaborate a little bit on the idea of displacement or displacing technology?
Of this displacement of...
Yeah, because...
the way the actual movement, the way the whole thing actually moves, or...
Yeah, I mean, the idea really is robotics normally are more in an industrial environment, right? So I'm kind of taking it out and displacing it. It makes it for us as normal people, I would say, more approachable. And we thought that the idea of displacement might be a theme which kind of interests you or you work with a lot.
Yeah, I think...
Yeah, I guess for us it's super interesting to kind of in a way, we work with robots, but on the other hand, we don't what we are very often interested in is movement. So basically the robot allows us to move objects or itself very precisely and very basically you can do the same movement 1,000 times. So it allows us to control things that move. But on the other hand, we are really if we could have some invisible robots, it would be the most nice for us. So we really try to kind of very much make the robots as invisible as possible and really try to more think about everything else. And I think that's...
Yeah, I think we for us, coming from Arduino, where it allowed us suddenly to control, to program a physical environment. The robot is allowing us to also program the movement of an object. That's what really brings makes it really interesting. It's a bit like you're in the 3D software and you can keyframe the position of something in space, but now you can do it in real life. You can actually tell a glass I want you to move exactly like this over some time, very precisely, and you basically can program the world. And that's what is really interesting for us, is that suddenly you can think about everything around you, also in terms of algorithms, and also in terms of just rethinking how things can behave and move, and not just react to some sensor and then just having a light turning on. Suddenly you can actually move things, and that's quite interesting.
I think, yeah, that's super interesting. Also, I mean, the effect is super interesting, I think, because the installation, for instance, where you cast bubbles, I mean, for some, it might appear that this is a really human thing to do, right? It's kind of very human as a child, maybe, to cast some bubbles, and using technology to do this kind of also touches the creepy line and evokes some emotions. And I think your works really have that ability to kind of spread ideas or emotions. And I'm just interested in how you think the effect or the emotion itself can be part of the installation, or is that even something you think of a lot, or maybe not so much?
Yeah, I think like that's super important to us, to like kind of that we try to evoke emotions, and we try to kind of like speak about like sensitive subjects like nature and like the human life, or like basically a lot of kind of subjects that are important to us. And we don't think that working with robots or working with technology makes it it's not impossible to touch these subjects in a way.
But I think like definitely we know exactly that by working with robots, we have to be conscious about all these topics, about automation, about the disappearing workforce, like all this social impact, economical impact of robotics and automation on society. But I think also for us, it's a way of really looking at the actual reality behind all this scary discourse. There is a lot of talking about automation. There's a lot of scaremongering about it, but there is not a lot of actual experienceable situations. And for us, that's also why we do all these projects. It's about actually discovering what's the reality behind all this talk, because we hear a lot of people talking about automation, but we don't see a lot of new things that can be realized with this. So I think for us, it's also about reclaiming control of the public discourse about robotics. And so it's not about saying that it's good or bad, but it's about trying to see the actual reality of what's possible. So that's a bit what we try to do. We try to really experiment by ourselves, and not just like listen to what some other people want to tell us about it. The major thing we noticed also is that because robotics have been sort of like in an ivory tower, kept by like big corporations, and like used to be like mostly controlled by very experimented engineers, or it used to be also that it was very expensive. So it made it that the narrative of robotics was controlled by big companies, essentially, like big private interests. A bit like when the Internet of Things was a huge thing, or like 3D printing is still, you have grassroots movements, but you also have huge companies that want to control the narrative of why it's good and why it is the future with this. And so for us, it's a bit about, proposing an alternative narrative about what is possible, because everything we do in our projects, none of these companies are doing it. They want to decide what is the official version of the future of robotics and what we will do with them. And we think a lot of it is wrong, or it's just bullshit. And we just want to like try to propose our own version of a future with robots that can also be interesting, but not in this like futuristic movie thing with androids moving around. It can be also much more quirky, and also much more funny and playful, and still, like we might also in some project discover that it's just wrong to do this with robots. Like for us, the bubble blowing project is also about this. Like what happened when you replace these kind of things that used to be associated purely with humans, and suddenly it's done by a robot. Like, is it wrong? Like, I don't know. We don't have the answer in a way. It's but it's also part of the project to ask people, so what do you think about it? And everybody loved it. So yeah, like that's also the things. Like you talk about robots dehumanizing what we do, but when you actually do it, people love it even more. So that's, yeah, for us, we don't want to answer about it. We just want to propose projects, and then people can decide what they want.
Yeah, it really gives you the human side of the technology, I would say, and that kind of makes it approachable for a lot more people than only technicians. And I think that's kind of the strength also of those symbols like touching hands. I mean, everybody understands that even a baby, when it comes to the world, it knows what that means. And I think that is really the power of that approach in a way. I mean, for me, it would be interesting to know how do you think the future of this whole realm of robotics will evolve? And do you have like more an utopian or a dystopian view of it?
I think like what we see for the next years is that the technology for robots will get cheaper and cheaper. And so robots like the one we used will become more and more accessible to a wide range of public that are just the public that you would find in design schools, in art schools, in fab labs. And so the use cases will just explode in terms of what people do with these robots. Because right now it's just in like research labs in universities, and it's just in R&D labs in big companies. And so they have very, very clear ideas of what they want to do with these robots. When you put them in the hands of like normal people, let's say, they have completely different ideas of what to do with this. And you can see it with Arduino and all the things you can see in maker fairs, all this kind of stuff. Like it's a completely different approach to technology that's what you see when it's pushed by large big companies.
But
and
also,
so
we think that we have kind of a huge responsibility to kind of integrate robots in our everyday lives and in the future. I think that's also a bit what we are here for and try to address the questions. I mean, there have to be answers to these questions, and and I think people deciding on what roles robots can have in our lives must address all these kind of difficult questions, and it's almost kind of a philosophical questions and
philosophical and ethical, I guess. There are guys in the chat who wanted to ask, how do you really get started with those kind of things? I mean, are there any good sources you want to share how to work with your first robot arm or anything? Which is
basically, yeah. I mean, that's also kind of like really, really important to in our kind of studio. We both studied graphic design, and we have kind of like, we work with the CNC. We have like metal, like we have a lathe, a mill. We have a lot of kind of machines, and we have robots, and we basically just spent a lot of nights on YouTube and learn, like watching videos. And basically, when we bought our first robot, we had literally never used one before. And just a few days later, we had our first job with it. We did some motion control. And we learned on the fly. And,
I think the major thing that if we have to tell people that want to get into it is just like be careful, first of all, because it's not like a 3D printer on your desktop. Like it can kill you if you make something wrong. So you have to be humble. But besides that, then it's actually not that complex in a way. Like it's just about the technology and the generation of robots. Like the interesting thing is there is a huge second-hand market. Like that's also why our studio is possible to exist. Like we can buy second-hand robots for fairly cheaply, and that's why we are able to have these robots and to use them. But then, like if any robot that is about 10 years old will be like really, really great. You will be able to do like super fantastic stuff, and the programming is actually very simple. Like if you know how to program G code for CNC machines, which is like really like you can write it in a text editor. It's about like, go to XYZ, go to XYZ, go to XYZ. The robot will do the same. You can write a text file and you can tell the robot, I want you to go to XYZ somewhere there and then there, make a pose. Then I want you to turn on some input, like output. And it's if you learn Arduino, you pretty much understand the whole way of working with these ones. Like the controllers for industrial automations are essentially just big Arduinos. they work the same. You have a little software and then like a little script that runs on it. They have inputs, outputs, and you just have a robot attached as well. So that's cool.
And maybe just as a last question, do you have any kind of weird tasks you made a robot do? Can you share some with us?
Weird tasks.
What you had a robot to do?
We
did some robot yoga once in a conference. We were kind of like in an afternoon. We were teaching some yoga classes, and basically the attendees of the workshop had to teach the robot some movements, and then at the end of the conference, the robot was giving the yoga class. I think this was kind of
yeah. We had a huge crowd outside following a yoga class done by the robot.
This is so nice. Hey, thank you very, very much for your time, and your talk was super interesting, and that you have been part of talks. Cool to have you.
Thanks for having us. Super nice.